In this lesson, we're going to be talking about gauge manifolds. This is part of the core air conditioning material. The gauge manifold consists of a low side gauge, which is a compound gauge. Low side gauge is normally blue in color, but not always, and it's usually mounted on the left side of the manifold. The compound gauge will read a vacuum as well as a pressure. The second gauge is a high pressure gauge, high side gauge. The high pressure gauge is usually red in color, and it's usually mounted on the right side of the manifold. And there's at least two hand valves, usually on the left and right side or on the left and right front side of the manifold. A gauge manifold allows a service technician to check the operating pressures of both the low side and the high side at the same time. The operating pressures of the system are read in pounds per square inch. The gauges read the pressure from the hose under each gauge without opening the valve. In other words, make sure your valves are closed before you connect the gauges. The gauges will also allow the technician to add and remove refrigerant, add refrigerant oil, bypass the compressor, and perform many other service operations. So this is a picture of a gauge manifold. You have your two gauges. Low is the blue, high is the green. You have your high pressure gauge, compound gauge, low side valve, high side valve. Again, the valves are closed to give the path to the gauge by itself. You have the connections, you have a sight glass sometimes, okay, and then you have additional ports on the left and right side. Low side pressure gauge reads the pressure through the whole low side of the system, from the metering device to the compressor. High pressure gauges read the pressures on the high side of the system, from the compressor to the metering device. Under normal circumstance, you will see the same pressures all the way through the low and the high side of the system. Okay, in other words, it doesn't really matter where on the high side you're connected. Doesn't really matter where on the low side you're connected. You might see a PSI difference if you have a large evaporator coil, long line set, or a very large condenser. But it's not enough to make a difference under normal circumstances. You can always say there's an oddball situation, but 99% of the time you should see relatively close to the same pressures. Manufacturers color code the low and high side of the gauges. Blue hose to the low side of the system, red hose to the high side of the system. The hand valves on the side of the manifold separate the gauge pressure chamber from the manifold center chamber. The center chamber is located between the low and the high side of the gauge manifold. A yellow hose connected to the center port is connected to a refrigerant cylinder, a vacuum pump, or a recovery machine. Some gauge manifolds have a sight glass that can be used to view the flow of liquid through the center chamber. It can also be used for charging or recovering liquid refrigerant. Not all gauge handles have mechanical gauges. Some are digital. Some gauges have additional features such as thermocouple temperature clamps or computer software. Digital gauges are useful because they're capable of being programmed to use with many different refrigerants and can display saturation temperatures as well as pressures in different units of measurement. The rubber O-ring prevents refrigerant from leaking out around the valve stem. When the valve is turned counterclockwise, the valve plug moves outward from the seat, opening a passage to the center port from one of the side ports. In order to prevent contamination and debris from entering a system, purging your gauges and hoses is necessary. Purging refers to the process of removing unwanted vapors, dirt, or moisture from the refrigerant hoses that connect the gauge manifold to the refrigeration system, releasing the contents into the atmosphere. Purging of refrigerant hoses uses refrigerant as the purging agent. When purging, release as little refrigerant as possible to reduce the impact on the environment. Use quick connect fittings greatly reduces the amount of refrigerant release. Quick connect fittings are spring-loaded brass fittings which seal off the refrigerant inside each hose. Older gauge sets can be retrofitted with quick disconnect fittings. Okay, you can actually buy these. Even you can get them on Amazon if you have to. To purge the gauge manifold and refrigerant service lines, begin by making sure that the cylinder valve and gauge manifold valves are closed. Service valves should be back-seated to ensure they're completely closed. Connect the center line of the gauge manifold to the refrigerant cylinder containing the same refrigerant as used in the system. Remove the caps from the system service ports and loosely connect the gauge manifold's low and high side lines for purging. Open the low and high side valves on the gauge manifold. Briefly crack open the service valve on the refrigerant tank to flush the gauge manifold and service lines with refrigerant. Any moisture, debris in the line should be forced out of the loose connection at the service port. Close the cylinder valve, tighten the service lines fitting at the ports. The service valves can now be opened without fear of contaminating the system. Okay, so again, this is how they connect. You have the red hose on the high side, blue hose on the low side. Low side valve and high side valve should be closed unless you are using the yellow line. Don't open those if you're not using the yellow line connected to a cylinder or some other device. The operation of the gauge manifold consists of opening and closing high and low side valve handles. So again, if your high side valve is closed starting from the top, and your low side valve is closed, okay, the center is capped off. There's no connection. There's no refrigerant flow to the center. Okay, if it's connected to the vacuum pump, you want to open both. If it's connected to a vapor charging cylinder, you only open the low side. If it's connected to a liquid charging cylinder with the system shut off, it's only connected to the high side to charge as a liquid. But again, the system cannot be running. The procedure for connecting gauges to a system depends on the system design. Some systems have both a suction service valve and a discharge service valve. Some have a suction service valve adapter mounted in the compressor. Some do not have any service valves but have a process tube. Some have a process tube that is too short or inaccessible. Okay, these are just some of the different areas that you can use to connect to refrigerant lines. You have the valves up here in A. You have a valve adapter up on B. You have a process tube over on C. And then you have a piercing valve over on D. Now, once you add a piercing valve, you have to recover the refrigerant and put in a true Schrader core because you cannot leave a piercing valve. They leak. The refrigeration system and the analyzers combine the gauge manifold, temperature sensors into one package. They can also include digital connectivity and some other troubleshooting capabilities. Refrigeration system analyzers are used to measure system variables such as pressure, temperature, help determine whether operation is optimal, or measure superheat and subcooling to indicate whether a system charge is correct. They also have data logging capabilities to allow technicians to keep track of a system operation over a period of time. This is an example of a refrigeration analyzer. You have your temperature clamps, you have your pressure, you have your transducers, you have your hoses, you have computer connectivity via USB. Okay, this is more and more techs are carrying these. I carry the Testo smart probes, same basic principle. My phone is what actually I use to read the pressures and temperatures on.